Hey guys, today we are going to start our next unit, and it is about the law of sines and the law of cosines. So we're going to start with the law of cosines, and we're going to ask ourselves, how does the law of cosines help me solve oblique triangles? And an oblique triangle, all that means is that you're looking at a triangle that's non-right. So before, when we used our trig, all of our trig functions and sine and cosine and all that stuff, we had to have a right triangle. Now we're going to get to learn how we can use trig functions without having a right triangle. So this is the law of cosines, and it is on your little teeny tiny formula sheet, and you will always get to have that on your test, so no need to memorize. And so basically, when we draw a triangle out, whenever you draw one, and mine looks pretty bad, remember you have big letters that represent your angles, and then the little letter goes across that is corresponding. So you have big C across from little c, and little a across from big A, and little b across from big B. And the cool thing about this formula is, if you notice, it looks very similar to the Pythagorean theorem. So if you, for instance, had a right triangle where your angle C is your 90 degrees, and you did cosine of 90, because it says cosine of C here, that equals to 0. And as soon as you zeroed out this piece, and you don't have to cross this out once you've written it down, but once you get rid of that, you zero it out, you notice that it looks like the Pythagorean theorem. So it basically is the Pythagorean theorem. It's just now we can use it with triangles that are non-right. So the hardest part about this is to remember how your triangle is set up. So you're always going to want to draw a triangle to go with your problem. And if you notice here, your isolated variable, the one that's all the way on its side by itself, goes with the angle that you use. So if you're going to change your letters, and if, for instance, you were needing to find side B or something, you would have to have B squared equals to A squared plus C squared, the other two sides, minus 2, then AC, and then the cosine of that angle. So your isolated side and your angle are always going to match using this formula. Okay? So again, this is how we can solve things that are non-right, triangles that are non-right. So let's go through some examples. The first one right here is they give me a nice little picture, and they tell me, well, they probably should tell me some side lengths, so I'm going to go ahead and put those side lengths in that I can see and you can't see. Okay, so we have triangle XYZ. We know that this side is 7, this side is 5, and then the angle between them is 39 degrees, and we want to find XZ. Okay, I'm going to go ahead and label that side Y, because it's the angle, or it's the side that's across from angle Y, so it's little y. So all we have to do here is use that formula. So if you notice, the side we're looking for is the one that's across from the Y. So we're going to write y squared, I'm just using my law of cosines here, equals my other side, so I'd have x squared plus y, or z squared, the other side, and that's going to subtract from 2 times 5 times 7, the sides that aren't y, times the cosine of the angle that's across, so 39 degrees. So if you notice here, these guys are across from each other, so the isolated one goes with the angle that matches. Okay, this is now something that you can type into your calculator and solve. So the one thing to notice here is we are in degrees, so you're going to want to make sure your calculator is put into degrees. And for this unit, it's going to be in degrees because we're looking for triangles here, and radian measures don't really help us with triangles. And then you can just go ahead and type this in. Now, you know that this is y squared, so I'm going to go ahead and have to take the square root in the end. But if you want to just be safe here and just type in what's over there on the right side, minus 2 times 5 times 7, and then the cosine of 39, and then take the square root, that's fine. So you would find this answer, and then square root of second answer. Try to use that second answer button a lot here, so that way we can get as precise as we can. Okay, so once we find this answer, we find that side y, and I'm just going to round to 2 decimals, so 4.427. 4 point, I'm going to write instead of just talk, 4.3. So that's that side length. And you can do a reality check here just to make sure, since 39 is a pretty small angle, and it's probably going to be your smallest angle here, this side is small to match with it, and it is the smallest side. So make sure when you have your triangle completed it makes sense at what you get. Okay, so that's one application of the law of cosines. The next application is going to look like this second example down here. I'll draw a line so I'm not confused. So they give me a equals 9, b equals 7, c equals 3, and we need to solve for the measure of angle b. So your first step here is you need to draw yourself a picture. Remember, we're not dealing with right triangles anymore, so it doesn't matter how ugly your triangle looks. Also, you cannot use Pythagorean theorem here, because if you notice, c would be my hypotenuse, and it's a lot smaller than all the other sides. So I'm going to label my triangle A, B, C, and remember that the small letter goes across from the big letter. So if A is 9, A goes right here, B goes across from B, and C goes across from C. So if they give me all the sides, and then I'm looking for the measure of angle B, so I want this one, we're going to use all the information that we used before. It's just now it's a little bit more tricky to solve for it. So if I go ahead and I plug in this triangle into my law of cosines, remember, I'm looking for the measure of angle B. So I'm going to look for the side across from it to be isolated. So I'm going to have 7 squared equals to the other two sides squared minus 2 times 3 times 9, the other two sides, and then the cosine of angle B. So when I look here, this is just like when we were solving those trig equations before. We want to isolate that cosine so then I can take the inverse of it. So in order to isolate this cosine, I'm going to go ahead and take 7 squared and subtract 3 squared and 9 squared. So I'll do 7 squared minus 3 squared, which is 9, minus 9 squared, which is 81, and you get negative 41. And then I have this little thing going on over here. Remember, it is negative. So I'll have 2 times 3 times 9, which is 54. I'm not even going to calculate that out. 54, and remember, there's a negative in the front, and then cosine B. Then all I have to do here is divide by negative 54, which will give me a positive 41 over 54. And then this is just like what we did before. We're going to go ahead and take the inverse cosine of both sides, so then b gets by itself. Take the inverse cosine of 41 over 54, and that should give me the measure of angle B. Again, you need to be in degrees for this, and all you have to do is do second cosine, that's the inverse cosine, and then 41 over 54. Okay, we're going to go ahead and round to the nearest degree. So the nearest whole degree, 40.6, would round up to be 41 degrees. And that's my answer. Okay, so those are the two applications of the law of cosines. All you got to do is think about what you have and which side needs to be isolated, and then you just solve it out using your calculator. I will see you tomorrow.